Good afternoon, everybody. I am Sravani Rani Mishra, and today we are here for the second project of the 9 to Tetris course. Now, in the first part, we have covered about the Boolean logic. So today we are here for Boolean arithmetic. We have already covered about the basic chips, basic gates, and their different versions like 16-bit, 4-way, 8-way. Now we'll implement them to create Boolean arithmetic. So the centerpiece of any computer is the CPU, the central processing unit, and the centerpiece of that CPU is the ALU, arithmetic logic unit. So in this project, we will gradually build a set of chips, culminating in the construction of the ALU chip of the hack computer. All the chips built in this project are standard except for the ALU itself, which differs from the one computer architecture to another. Now, these are our contents for this project. We'll work on a total of 6 chips, which are half adder, full adder, add 16, increment 16, ALU, and ALU another. Before going to our half adder, let us first know what is an adder. Now, as the name suggests, it's an adder. It adds two things. We give it two inputs or three inputs, so number of inputs is not valid now. We give it input and it adds the inputs and gives us an output. Now then what is half adder? Now half adder is where we come to the number of inputs. In half adder we give two inputs and it will give us one output. Actually it will give us two outputs. One is its sum and one is its carry. Now sum function is like the XOR of the inputs and the carry function is like the AND of the inputs. But actually the sum is like the result we get after adding these two numbers, and the carry is the overflow of this addition. In here in this code we can see our inputs are 1 and 1 and our sum is 0. Now XOR of 1 and 1 is 0 and our carry is 1 and the AND of 1 and 1 is 1. But as we know what actually happens is we add two numbers and 1 when we add it, our answer comes 0 as here and 1 goes to the next bit. But since our inputs and outputs both are in one bit only, so answer of the sum will come as 0 and we'll get a carry of 1. Next we have our full adder. Now what is the full adder? We have already discussed half adder. In full adder we have three inputs, as we can see here. As we can see here, there are three inputs. And similar to the half adder, the sum is the XOR of all three inputs and the carry is the AND of the all three inputs. But what actually happens is sum is the output of adding all three numbers and the carry is the overflow that happened in this addition. When we add three numbers in binary, our sum is usually 1 and carry goes to the next bit. Next we have add 16. Like in Boolean logic we had 16-bit versions for every gate. Here we have 16-bit version for the add function, where our inputs will be of 16-bit and our outputs will be of 16-bit. As we can see here, there is a number, a 4-digit number. That actually doesn't mean that the input is a 4 bits. When we write all the 16 bits of a number, every 4 bit is taken as one number and it is written in the decimal form here, but actually it's just 16-bit number which adds. As we can see here in the script, these are 16-bit numbers and they are added to each other, but while we write our input we write it in a 4-digit number. Next we have our increment. Now we can always use a +1 in our code, or we can have a built-in function for this operation which is very commonly used, like incrementing, adding 1 so that the loop continues. So we have this function increment where it's built in to keep on adding 1 to the value that is given. Your increment 16 depicts that it is a 16-bit incrementer where a 1 is added to the 16-bit input that we have already given it. As we can see here it is -5. Our input is -5. Now what happens when we add 1 to -5? We get -4. and output depicts the same. Next, we have ALU. Now, ALU is the most important part of this project. As I have already said, ALU is the centerpiece of the CPU and it differs from computer to computer. It is very carefully planned to effect all the desired ALU operations logically using simple Boolean operations. Therefore, the physical implementation of the ALU is to implementing these simple Boolean operations following their pseudocodes. So our first step is like to create a logical circuit that manipulates a 16-bit input according to the NX and ZX control bits. That is, the circuit should conditionally zero and negate the 16-bit input. This logic can be used to manipulate the X and Y inputs as well as the output. Chips for bitwise and adding and addition have already been built in this, and in the previous part we have already learned about that. So now what remains is to build the logic that chooses between them accordingly to control it. As we come to an end of this chapter, I hope all of the parts were clear. Thank you.